Thank you. Hello, everybody. My name is Vasileios Friligkos, or Vasilis, or Bill, whatever you like. And I'm working as a security analyst for the Cert of Intrinsec. Today I will present you how we can detect suspicious activity, botnet activity, in our IT infrastructure using correlation techniques. So just a reminder, this is a short talk. I won't get really into details. It will be more or less a high-level approach. But if anyone wants to discuss deployment techniques or details, I'll be happy to discuss with you. So, we all know how different botnets can be. They come in different sizes and shapes, depending on their architecture, how they communicate, what protocols they're using, the actual infection and propagation techniques they use, as well as the malicious actions being performed, depending on the motives of its controller of the botnet. However, what we also know is that they share some basic common characteristics, which are, for example, the need to infect, the need to have access to the resources of the machine, the need to propagate in order to have a net and not just one bot. And they need to do all that while being orchestrated. They need to be coordinated by a commander in order to perform the actual malicious action. So, what we are going to do is we're going to use these elements and these characteristics to help us identify botnet activity, suspicious botnet activity in our IT infrastructure. In order to do that, well, first of all, we have to centralize all data. Because in an IT infrastructure, we have firewall data, we have IDS data, we have antivirus data, we have all kinds of logs. We need to centralize all of that in one place so as to be able to have an overview of what's happening across our IT infrastructure. And on top of that, we need to formalize, we need to find a common description protocol so as to be able to treat all data equally under the same way. Once we do that, there is a need of data aggregation. We cannot treat all the data we receive. We have to aggregate and keep the essential information. We have to keep what's important and discard the rest in order to be able to apply rules of correlation that can be either temporal, meaning a sequential order of events. We have first A, then B, or spatial, which actually means we correlate between different sources of events. We have one event coming from our firewall and another event from our SQL server activity. We can correlate between these events and conclude something. And we can do that either based on rules, signatures. If a special match has happened, then we do or we do not do something. Either based on statistical deviation. For example, we pass a learning period, we learn what's normal and what's not normal, and any deviation from that behavior is reported. So, let's concretize all that. We have a typical IT infrastructure, external DMZ, internal network. We have all kinds of equipment that can send logging, that can send log data. We need to collect, first of all, locally, all the information. For example, we can collect firewall data, IDS, antivirus data from hosts or system-wise, servers running in our network. Once we do that, we aggregate the big amount of data in order to keep only what's essential, as we said, and we send the information after it's been formalized to our correlator, which is actually the analyzing machine that's going to provide us with all the intelligence and with all the necessary data to perform an analysis. Because all this has as a final destination, a security analyst who will look into what's going on and what's happening. So, let's take a scenario where we could apply all that. Let's imagine we have a new variant of a malware, meaning there are no antivirus detection signatures, no IDS signatures. We cannot be based on blacklists, URLs or IP domains. And let's also suppose that the malware has already infected the network. We have no infection vector to detect. So more or less we can say there are no conventional means of detection. We cannot be based on antivirus companies, on researchers, on anything like that. What can we do? We can still detect deviations from normal behavior. And what I mean by that? For example, unusual traffic. Let's say, for example, we have some high-level ports utilization. Let's say we have a high amount of TCP control traffic. We have a lot of SYN, SYNAC, FIN traffic comparing to normal data exchange traffic. Let's say, for example, we have a honeynet in our network that's never supposed to be reached, and a machine is trying to contact it. Another example could be, for example, a machine that's stuck on 100% CPU. It probably means something's going wrong. Or, for example, a more general deviation from normal behavior. You see one host receiving one kind of behavior, and then after a while repeating the same behavior towards another host. So, again, let's concretize all that. Let's take, for example, zero access. Everyone, I guess, knows more or less what it's doing and what's happening. So we have a machine in our internal network. It gets infected by zero access. First thing zero access does is to get the location of the infected machine, and it's doing it using MaxMine's geolocalization services. So, just a request, and let's just say for the moment that passing through our proxy server, the URL, the user agent are being recorded, but nothing more than that. Second action, to actually install and report to its command and control center using UDP 53, so using normally DNS traffic, but of course it's not DNS. So our ideas will detect that we have malformed DNS traffic, and on top of that, it's not towards our designated DNS server. It's going somewhere else. Again, just an event being recorded, it's nothing suspicious. Third, the zero access is actually trying to communicate with supernodes to start performing and receiving commands, and it's doing using port CPN UDP 16471, so a really high-level port. Our firewall can also log that information as unusual high-level port used. Last action, the actual malicious action being performed by zero access, Bitcoin mining, locking our machine into high overload of CPU consumption out of backups hours, let's say, or out of high activity hours. So each one of these events by itself, it says us nothing, because if we start alerting for each event that's deviating from normal behavior, we will be flooded with false positives, and we don't want that. False positives can hide real attacks and can give us an efficient detection technique. However, what can we do is correlate between all this information. For example, malformed traffic, DNS traffic, going somewhere that it should not suppose, it's not going to our DNS server, unusual communication to port 16471, and also an unusual CPU overload to the same machine. All this can indicate a potential infection, meaning that the security analyst must investigate, see what's happening, why do we have 3 events coming from the same IP address. And so he starts investigating, he sees that indeed the machine is infected. What can he do? Well, he can extract artifacts of and behavior associated to the malware in order to be able to construct indicators of compromise. That's just a way to say, I gather intel on the malware and I put it together, so to be able to relaunch an investigation on my IT infrastructure to further enhance detection techniques, because maybe we discovered one host who's infected, but we can further enhance, now that we know what's going on, to detect other hosts that are infected. Again, taking the previous example, what could be an indicator of compromise? For example, DNS traffic not going to our DNS server, and on top, after our analysis, we discovered that the 8th and 9th byte, for example, are representing our country code, XORed and encrypted, but still, since our machines are located, let's say, on the same perimeter, it could be used as an indicator of compromise. Or, for example, using our proxy server logs, whenever you see the user agent that zero access used, well, alert me, because there's probably an infection, and many other examples. So, arriving at a conclusion, what can automated correlation help us do? Well, first of all, it helps us obtain a situational awareness. It helps us know what's happening in our IT infrastructure, and helps us identify what's normal and what's not normal. By monitoring and knowing what's going on, we can see if something is not going well. We can detect it, because that's not the normal behavior I'm having. On top of that, it can help us decrease the false positives by correlating multiple events together, so we are not based on one single event, but multiple events. And as we saw, also increase detection rates by helping us detect more complex patterns of attack and infection. However, what it cannot do is completely replace human intervention. Always, in the end, there will be a human who will analyze and will investigate upon the event, and either decide that it should be investigated and extract artifact and behavior. Either he will realize that's a false positive, and he will adapt his detection techniques to further reduce false positives. So, and by that, I'm concluding. I think it's okay. We have some time. So, if anyone has any questions, I will be happy to answer. Yes.
Alex from Luxembourg. I have a small questions. You mentioned that you are doing baselining, or you are doing kind of, way of classifying the traffic that is normal from the one that is infected. And how do you do this baselining when you have already infected machines?
Well, actually, this is a limitation. In order to have a secure baseline, you have to know that you're not infected. And theoretically, you can never know that you're not infected. But this is indeed a limitation. You can only trust your network that for a given moment it's not infected, and go through a learning phase, assuming that you're not infected, and then seeing the difference. But it's indeed a limitation of the technique.
Tom from Switzerland. Very nice presentation, very interesting, thank you. It's focusing mostly on network-based indicators, and using the terms indicators of compromise. There would also be ways to detect malware based on host-based indicators like registry keys or file hashes that are known bad. Or if you have a clean image of your system, you could make a baseline of all your known good files, and then look for anything that's not in the whitelist. So I think it's a very good approach for network-based detection, and I'm also interested in using indicators of compromise for host-based detection, where you can look for suspicious registry keys, for persistence, suspicious process behavior, for mutexes in memory or something like that. So this is a good approach for network-based detection, and it would be nice to have a combination for also host-based in detections.
I see.
But it's very good. Also, one of the anomalies, like if you have a certain domain that's accessed for the first time, there could be a pretty good probability that would be a malware domain. But as you say, it's suspicious, and it could be that some user is just visiting a new web page for the first time as well. So yeah, you have to use different indicators to get a high probability. Itself,
it's not a very strong indicator, but in combination it could be a really good sign.
Yes,
as you said. And also regarding host-based indicators of compromise, it is indeed a very valid point. It's just that you cannot really have this visibility across your IT infrastructure. you will have to do more focused research. Whereas network, you already sniff it, you already record it. It's more easier to deploy it across your IT infrastructure and automate it also. But of course, there are more targeted host-based indicator commands. Of course, are more targeted, more valid, more efficient, and more widely deployed.
Hi, it's Sarah from Berlin. I was wondering, when you first set up the aggregation itself, did you do any feature selection that was mostly manually based? Like, did you set up rules in terms to extract features? Or did you use any machine learning approaches to be selecting features on the fly?
Sorry, could you repeat because I didn't hear you?
Excuse me. I was wondering whether you had a manual or a computerized feature selection in terms of aggregation of the data.
Okay. Well, then they are configured manually depending on the equipment that's being aggregated. I mean, we're not using the same type of aggregation everywhere. Because, for example, from firewall logs or router logs, logging TCP traffic, we don't really need to have all the packets exchanged. We can have one summary of the IP addresses, the ports, and what has been exchanged, more or less. But for other machines, like our WAF, Web Application Firewall, then there we do another level of aggregation, which is much lighter, because a WAF doesn't produce so many events. So we cannot say we have a general aggregation rule. It's more or less manually configured in the beginning, and then adapted regarding the outcome. If you have too many false positives, you adapt, you reaggregate, you reduce, etc.
Any other question? Don't be shy. Okay. Thank you. A question?
Well, I have a question.
Yes.
Basically, the wider your infrastructure, the wider your infrastructure,
Yes.
the more data you have to gather, to collect.
Yes.
And then you have to face a volumetry problem. So that means probably you will have to drop earlier a part of that data. So how do you see your ability to detect low-profile threats on your network based on this problem, on this very problem? Because on a small scale, maybe it's feasible, but on a larger scale, you will either you will have a lot of false positive or a lot of data or not enough to detect this type of threats.
Okay. Well, actually, we don't drop data. In a perfect world, we would be able to aggregate data, meaning have a very large mass and volume of data, and keep only what's essential in, let's say, one log, ideally. This does not always happen, but we try to do that as much as possible, meaning that we try to reduce the size of the actual data without losing information. Meaning, I know it's not, of course, it's not 100% bulletproof. You will lose some information and you will have some false positives. But that's why you add layers of correlation to be able to decrease your false positives and have stronger indicators of compromise, meaning indicators of suspicious activity. But in general, you don't drop data, you aggregate it. You keep what's essential while decreasing the size. But you don't ignore, let's say, data.
Last tiny question? Okay. Thank you, Vasileios.
Thank you.